Okay, welcome back from break. Hope you guys enjoyed the 2-week long break, and hopefully everybody's doing well and coping with all these issues we're having to deal with. So we're starting chapter 3. Again, just a reminder, you should have printed out the notes. If you haven't done that, you might want to do that and then come back to this video later. I've already discussed homework on the online meeting that we had, so hopefully you're ready to go. All right, so we're dealing now with higher order polynomials, and we're going to do some division today. So here's our first problem here. We're dividing a polynomial, which means there are multiple terms, by a monomial. And again, monomial means we have only one term. So our monomial in this case would be the 4x in the denominator. So the simplest way to do this is to split this up into multiple fractions. So each fraction is going to have the same denominator, which is our 4x. So we're going to write these as individual fractions. Okay, so each one will be a single fraction, so we've got 16x to the third over 4x minus 8x squared over 4x plus 12x over 4x. Oops, left out the x there. There we go. And your simple rule for dividing these, we did this a little bit in chapter 1, is you're going to divide the numbers. And then for the variables, in this case is x, we're going to subtract the exponents. Now, just a reminder, each one of these x's that are by themselves, if this helps you, you may want to put a 1 here because each one of these technically have an exponent of 1. We just don't normally write that in when we're writing out our variables. So for our first one here, we got 16 divided by 4, which is 4. And for the exponents, 3 minus 1 is 2, so that gives us an x squared. Our second fraction, 8 divided by 4 is 2. And 2 minus 1 is 1, so we just have an x. And finally, 12 divided by 4 is 3. And for the x's, 1 minus 1 is 0, so the x's cancel out. So we just have a 3. So after we divide our polynomial by a monomial, here is the result you are left with. Okay. So we're not going to do a lot like this with just a monomial. We're going to be doing more of dividing a polynomial by another polynomial. So multiple terms divided by multiple terms. Okay. Now, there are 2 ways to do this, and I'm going to go through each one. The first one is using long division. Now, normally we are not going to use this because this is a much, obviously, longer method, and it can get a little confusing, okay? And I'll show you why as we go through this. But the only time you need to use this normally is if the x in the divisor has a coefficient. Okay, so actually this one, you can see we're dividing by x minus 3, so the x doesn't have a coefficient, so technically we wouldn't need to use long division in this case, but I'm going to go through it just to give you an example. So if we had something like 2x minus 3 or 5x plus 1, and we were dividing by those, then we would have to use long division. There's no other way around it. But we're going to do long division just so you can see the process. And then I'll show you a much shorter method that we're going to focus on and use for the rest of the chapter. So when you're doing this, just like we did with some of the things before in chapter 2, and especially the stuff in chapter 6 and 7, if there's anything missing, we need to replace that term with a 0. So if you remember, when we did systems of equations, if one of the variables were missing, we put in a 0 when we did Cramer's rule. Same thing here. We need to start with the highest exponent and go all the way down to the smallest exponent. And if there's a missing one, we put in a 0. So you can see here we're missing the x term, which should be in here. So in place of that, we're going to put a 0x. So we got x to the third minus 2x squared plus 0x plus 3. And it's long division, so it's just like you did back in, I don't know, 3rd grade or something. We're dividing by x minus 3. So the difference here is we're only going to start with just the x. We'll let the 3 kind of hang on for a while, and we'll get back to it a little bit later. So the way you need to think of this is a little different. Before, you would look at it and say, okay, how many times does x go into x to the third? Well, x goes into x to the third 3 times, but that's not going to give us what we need. The way you should think of this is, what do I need to multiply x by to get x to the third? So x times something is equal to x to the third, okay? And that something, so we have 1x, we need 3 of them, so that something is x squared, okay? Now we're going to use the minus 3 as well. So we're going to multiply this out just like you normally would with long division. X squared times x is x to the third. X squared times minus 3 is minus 3x squared. And then we're going to subtract. So remember, we're subtracting this whole quantity. So this minus 3x squared is actually going to turn into a plus. So remember that. So x to the third minus x to the third is 0. The first 2 terms will always cancel out. Negative 2x squared plus 3x squared is x squared. And bring down your next term, even if it's a 0. So what do we need to multiply x by to get x squared? Well, we need to multiply it by x. X times x is x squared. So x times x, x squared. X times minus 3, minus 3x. And again, we're going to subtract the entire quantity. So the first 2 terms always cancel out. X squared minus x squared is 0. 0x minus negative 3x, so that becomes a plus, gives us 3x, and finally bring down our plus 3. So what do I need to multiply x by to get 3x? X times 3 is 3x. So put a 3 up there. 3 times x, 3x. 3 times negative 3, negative 9. And again, subtract the entire quantity. So our minus 9 becomes a plus. The 3x's cancel out. 3x minus 3x is 0. 3 plus 9 is 12. And we don't have anything else to bring down, so 12 is our remainder. Okay. So the way you're going to write this, our answer is the value we ended up with. So x squared plus x plus 3 plus, we still have our remainder. And the way you need to rewrite the remainder is the remainder over whatever we divided by. So that is the x minus 3. So this would be your answer in WebAssign. And make sure you put the remainder as a fraction. Okay. All right, so that's long division. Again, the only time you need to actually use it is if the divisor has a coefficient other than 1, or if x has some sort of coefficient like these examples I gave you up here. Okay, so the other method is the one we're going to use the most, and we're going to go over that and do a couple examples with that. So I'm not going to do this second example, but you can see we're dividing by 3x minus 1. That one you would have to use long division, but again, we're not going to be messing or doing any of those. I think I took all of them out of the homework. So, All right, so synthetic division. This is the shortcut, a shorter method of dividing polynomials. So the nice thing about this is the variables are omitted or left out. We're only going to deal with coefficients, okay? And as I already mentioned, the coefficient of x has to be 1. If it's not 1, or if it's some other number, you have to use long division. And the divisor is in the form of x minus a. So here we're dividing by x minus 5. Again, this is in the form of x minus a. So a is equal to 5. If we were dividing by x plus 3, a would be equal to negative 3. So this is the number we're going to use when we're doing our synthetic division. So one way you can think of it is the number you use is always the opposite of the sign they give you. So x minus 5, a is positive 5. X plus 3, a is negative 3. Okay? So the first thing we're going to do, we're going to write down our coefficients from our polynomial. So from this polynomial, we get a 4, a negative 13, a negative 20, and a negative 15. Okay? And we're going to write, do a line there and a line down here. Notice I left some space underneath. We need that space. And then our 5, that's what we're dividing by. A is 5, goes over here. So 2 simple rules. Number 1 is add down. And number 2 is multiply up. Okay? And you do them in that order, and then you just repeat. So we're starting with the 4. There's nothing underneath the 4 to add, so the first number always just comes down. Okay? And then we're going to bring the 5 over, and we're going to multiply. And it goes up to the next spot. So 5 times 4 is 20. And then we're going to add these two together. Negative 13 plus 20 is 7. And then we're going to multiply. 5 times 7 goes up here. That's 35. Add these two, we get 15. 5 times 15 goes up here. That's 75. And add these two together, we get 60. So we're done with the long division, or I'm sorry, we're done with the synthetic division. Now we just need to write out our answer. So we started out with variables, we're going to end up with variables, but because we divided, the first variable is always going to be 1 digit less. So starting with our 4, we've got a 4x squared plus 7x plus 15. And the last number is our remainder. So that's going to be plus 60 over, that's an ugly 0. Let's try that again. Ugh. 60 over x minus 5. So here's our result after doing long division. So you can see it's a much quicker process. You only have to add and multiply, and add and multiply, and keep going until you run out of numbers. So let me caution you, please, 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 please be careful. Copy your numbers carefully. Copy these numbers carefully. Do your addition and your multiplication carefully. And as I've said before, use a calculator if you need to. All right, so that's synthetic division. Take a look at another one. I think I have another example. Yeah, here we go. So this one, if you notice, there is a missing term here. We don't have an x squared, so I need to put a 0 in place of the x squared. So my coefficients are actually 3, 0, negative 7, and 10. And because it's x plus 3, that means a is equal to negative 3. So that's what we're using for our synthetic division. So again, bring down the first term. Negative 3 times 3 is negative 9. Add these together. Negative 3 times negative 9 is positive 27. If you need to write a plus there just to make sure you get the right sign, that's fine. Negative 7 plus 27 is 20. And negative 3 times 20 is negative 60. So we're left with negative 50. Remember, this is your remainder. You can put a box to separate it if you need to. So our answer here is 3x squared minus 9x plus 20 minus 50 over x plus 3. And since this is negative, that's where our minus comes from. Okay, so that's synthetic division. So when the question says divide, and that's it. It doesn't say to do anything else with it. It doesn't say to use any other theorem or math term or anything like that. This is all you do. Just divide and write your answer. Okay? But we're going to use this for a couple of theorems. The first one is the remainder theorem. Okay? So before, when you had a function and they said find f of 4, we plugged in 4 in place of all the x's. Well, now the function's pretty big, and we've got some big exponents in some cases. These aren't too bad. X to the third isn't so bad. But if we had x to the fourth or x to the fifth or even higher, you'd have to do quite a bit of calculations to get your answer. Excuse me, that was my drink out of water. So we're going to use synthetic division to find the value of the function. So the remainder theorem basically says that the remainder is the value of the function at whatever value we're putting into synthetic division. So we're going to use synthetic division to determine the remainder. So notice it says use the remainder theorem to find p of 3. So I could take 3 and plug it in for every single x and do all those calculations, or I can do synthetic division. Now, the value they're giving us is a. Notice this isn't in the form of x minus a, it's just a, p of a. So you don't use the opposite here, you just use that number. So we do synthetic division again, bring down the 1. 3 times 1 is 3. Add that together. 3 times negative 2 is negative 6. Add that together. 3 times 0 is 0. Add that together. And we get negative 18. So p of 3 is equal to negative 18. So if you plugged everything in, back in here and put 3 in place of this x, 3 in place of this x, 3 in place of this x, we would get negative 18. So just a short way to get that. So when you see the remainder theorem or you see find p of something, then you're looking only for the remainder. So our answer in this case is just negative 18. Okay, we don't need the rest of this. We just need the negative 18. Okay, let's take a look at another one. So here's our polynomial. They want us to find p of 2. So 2 is the value we're going to use in synthetic division. So we have 2, negative 1, 3, negative 1. And we're going to do synthetic division with 2. So always remember, bring down your first number. There's nothing to add to it, so it always comes down to the bottom. 2 times 2 is 4. Add that together. 2 times 3 is 6. Add those together. 2 times 9 is 18. We add that together. P of 2 is equal to 17. Okay? All right, so that's the remainder theorem. Now, notice all these had a remainder. When there's not a remainder, that means we're left with a 0. So if we get 0, so you can see here, it says if p of a is 0, then x minus a is a factor of the polynomial. So the question here is going to be, is a certain amount a factor? So we're looking for a remainder of 0. This is called the factor theorem. If the remainder is 0, then whatever we're dividing by is a factor of that polynomial. Okay? So your answers here are going to be either yes or no. Yes, it is a factor. No, it is not a factor. Okay? So we take this first one. We got a 1, a negative 3, and a 2. X minus 2 means A is equal to 2. So that's what we're going to use for synthetic division. So bring down your 1. 2 times 1 is 2. Add that together. 2 times negative 1 is negative 2. We add that up, we get 0. So the question was, is this a factor? Because we got a remainder of 0, this is a factor. Okay. Let's try a second one. So now it's a little bit different. They're asking us, is A equal 3 a 0? So now they're giving us the value of A. They're not giving us a factor, so they want to know, is it a 0? So a factor would be in the form of x minus 3. A 0 is the value that makes this 0 when A or when x equals 3. So when we get a 3, let's say x equals 3. When x is 3, we get a 0 of the polynomial. So they want to know, is this an actual 0? So we're going to do synthetic division again, see if we get 0. Okay? So we have 1, negative 8, 22, negative 29, and 24. So this is a pretty big one. You can see if we were to plug in 3 in every one of these x's, it would take a while for you to do those calculations. With the synthetic division, it's a much, much shorter process. All right, 3 times 1 is 3. We add that together, we get negative 5. 3 times negative 5 is negative 15. That adds up to 7. 3 times 7 is 21. That adds up to negative 8. And 3 times negative 8 is negative 24. So, is this a 0? Yes, it is, because our remainder is 0. So basically they're asking you, if you plug this number in the function, are you going to get 0? Well, obviously we see that we did. So it is a 0 of the function. All right. The last thing in section 1 is actually nothing different or nothing new. It is really a different way to express your answer. Okay, so we're still doing synthetic division. We're still doing the entire process the same way, but when we get done, we're going to write the answer in a different form. And the way you know that it's going to be in that form is you're going to see the words reduced polynomial. Okay, so notice here in this question it says, write p of x, that's our polynomial, here's our polynomial we started with, as a product of x minus 3 and the reduced polynomial q of x. So when we divide, we get something smaller, so it's reduced, and the new polynomial they're calling q. So we're going to write it as x minus 3, that's what we're dividing by, times the answer we get after we do synthetic division. So we're just writing the answer in a different format. So we're going to do synthetic division. So we got 2, negative 3, negative 4, and negative 15. And we've got x minus 3, so that means a is equal to 3. Now, notice it says verify that it is a factor. To be a factor, we have to get 0 for our remainder. If you don't get 0, then you can't finish the problem. So they're kind of telling you to begin with, hey, guess what? You're going to get 0 for your answer, okay? Or for your remainder, I should say. So 3 times 2 is 6. Add those together. 3 times 3 is 9. Add those together. 3 times 5 is 15. So we got 0. So our answer is the product of x minus 3. We've already got that. And the reduced polynomial. Well, that's this part right here. So 2x squared plus 3x plus 5. So again, all this is a different way to write your answer. Okay, that's the end of section 1. Be sure you log in for office hours if you need additional help or have any questions on your homework. Don't forget to get your homework in. The due dates in WebAssign are the current and correct due dates. So make sure you pay attention to those. Extra credit still applies to homework if you get it turned in 24 hours in advance. And again, you can email me, message me on WebAssign, or show up for office hours online, and you should have gotten an email that shows you the times for office hours and the meeting code for that. So we'll see you next time, and I will let you know as soon as we have a quiz or a test scheduled and the details for that. Okay? Talk to you later.